Okay, so we're being asked to factor this quadratic. And so what I'm going to notice first is that both terms have a 192 in common. And they also have a D in common. But before anything, before I get into the more challenging piece, let me factor out the 192 and the D from both of those terms. And what we're left with is going to be a Q squared minus a 1. Now, just to help us connect everything, notice that if I were to multiply the 192D times Q squared, we would end up with 192D Q squared. And then 192D times 1 is 192D. Okay? All right. So now, let's look at this we're left with a binomial inside the parentheses. And what I want you to notice is that Q squared is a perfect square. And notice that 1 is also a perfect square. And not only that, but we have a minus sign here. So when we have a difference of squares, it's helpful for us to remember that we may have worked with these before, but when you have A plus B and A minus B, and you FOIL this out, so it would be A times A gives me A squared. A times minus B is minus AB. B times A is plus AB. And B times negative B is minus B squared. Notice that these two terms cancel. And what you're left with is A squared minus B squared. Okay, so where am I going with this? I want you to notice that in this scenario, you have a perfect square. For the first term, you also have a perfect square for the second term. And you have a difference over here. So again, you have a difference of squares, which looks a lot like this over here. Now, if I were to go from this situation to the factored form, what I want you to notice, I'm going to clean this up just a little bit so you could see a little better what I'm trying to point out. You end up with an A plus B and an A minus B. We call these conjugates. Okay? So in this case, notice over here we have an a squared, which is a lot like the q squared. So if you take the square root of a squared, you get a. And if you take the square root of q squared, you get q. I'm just going to write that here. If you take the square root of b squared, you get a b. And the b shows up here, and the b shows up here. If you take the square root of 1, you get a 1. Okay, where am I going with this? That whenever you have a difference of squares, you can factor it and end up with what we call conjugates. Let me write that down. To get conjugates, what you do is you take the square root of the a squared, which is a, the square root of the b squared, which is b. In this case, we're taking the square root of q squared, which is q, and the square root of 1, which is 1. And you put a plus sign in one of the binomials and a minus sign in the other binomial. And you use these answers to fill in these places here. And so what we're going to submit as our answer is that expression. First, we factored out a common term, and then we factored the difference of squares using this work here to guide us. And this is the final expression.